Settle in for a slow, sleep-friendly journey through the story of Pluto. This 2-hour video is soft-spoken and unhurried, built to quiet your thoughts and ease you gently into rest. We'll drift through how Pluto formed out in the Kuiper Belt, why it was reclassified as a dwarf planet, and what we've learned since, because Pluto isn't a dead little ice rock. It's a surprisingly complex world with a thin atmosphere, changing seasons, and a surface shaped by exotic ice and slow geology. We'll glide over the bright heart-shaped region, the mountains made of water ice, and the strange plains that look like they're being renewed over time. Then step back to understand Pluto's relationship with Charon and its other moons, locked in a quiet orbital dance far from the sun. No jump cuts, no harsh sounds, just gentle narration and a calm night atmosphere. Perfect for sleep, relaxation, anxiety relief, or background listening. Let Pluto do what it's always done, drifting at the edge of the solar system in cold silence while you fall asleep. Pluto is the kind of world that forces your brain to stop using the inner solar system template, because out there distance changes everything. Light is weak, temperatures are brutal, time is slow, and yet Pluto still manages to be active in ways that feel almost unfair for something so small, like a tiny planet that refused to be simple. Pluto lives in the Kuiper Belt, a cold region beyond Neptune, filled with icy bodies and leftovers from early solar system construction. And the important point isn't the label dwarf planet. It's what the location implies. Pluto formed from the same outer disk material that built many Kuiper Belt objects, so it's a relic of the early solar system preserved in deep cold. But preserved doesn't mean frozen in time, because Pluto's surface and atmosphere change with seasons that last decades, and its geology shows evidence of renewal, meaning Pluto has been moving, flowing, and reshaping itself long after people assumed it would be dead. Pluto's orbit is eccentric and tilted, so its distance from the Sun changes a lot over its long year, which is about 248 Earth years. And that changing distance matters because Pluto's surface is covered in volatile ices, nitrogen, methane, carbon monoxide, that can sublimate into gas when warmed and freeze back out when cooled. So Pluto runs a slow, volatile cycle where frost migrates across the surface, feeding a thin atmosphere when sunlight is stronger and collapsing back onto the ground when the world cools, like a planet that breathes once every few human lifetimes. When Pluto is warmer, some nitrogen ice sublimates and builds an atmosphere thin but real, with haze layers that can form in the upper atmosphere as sunlight and energetic particles trigger chemistry, producing complex hydrocarbons that can settle back down and tint the surface. And when Pluto cools, that atmosphere can partially collapse as gases freeze onto the surface, meaning the sky itself can come and go, an atmosphere that's not guaranteed, but seasonal, like a temporary skin. Pluto's surface is a patchwork of terrains with wildly different ages and textures, and the most famous is the bright heart-shaped region, a two-lobed feature with one lobe being a massive, bright plain of nitrogen ice that looks like it has been resurfaced relatively recently compared to heavily cratered regions elsewhere. And that matters because a smooth plain on an ancient outer world is a sign of activity. Something erased the craters, something renewed the surface, and on Pluto that something is likely the slow flow and convection of volatile ice. Nitrogen ice at Pluto's temperatures can behave like a soft solid that flows over time, like a glacier, but with the working fluid being nitrogen instead of water. And if you imagine a thick layer of nitrogen ice warmed slightly from below by internal heat or by absorbed sunlight, it can convect, warmer ice rising, cooler ice sinking, creating cellular patterns on the surface, and Pluto's bright plains show polygonal-looking cells consistent with that kind of convection, like a frozen lake surface patterned by slow motion underneath. That's the first big mental flip. Pluto has glaciers, but they're not water glaciers, They're nitrogen glaciers, and they can creep and reshape a landscape at temperatures where water is as hard as rock. Water ice on Pluto is effectively bedrock, so mountains made of water ice can stand tall like stone mountains, while nitrogen and methane ices can move like glaciers, and that reversal of what's rock and what's ice makes Pluto feel like an alternate version of geology where the materials have swapped roles. Pluto's mountains are a second shock because they're real relief, not small bumps, tall, rugged ranges made of water ice that indicate Pluto can build and sustain topography. And to build topography, you need strength in the crust and some internal processes that can uplift or expose material, whether through tectonic stress, cryovolcanism, or the mechanical effects of freezing and expanding subsurface layers. Pluto shows evidence of fractures and fault-like features, long cracks and scarps that suggest the crust has been stressed, and one plausible stress source is the slow freezing of a subsurface ocean. If Pluto once had or still has a deep ocean layer beneath the crust, the gradual freezing would expand volume and push on the crust, generating extensional tectonics and cracking the surface. And even if the ocean is partly frozen now, the tectonic signature could remain, meaning Pluto may have been warm enough inside at some point, through radiogenic heat from radioactive elements, to keep liquid water stable under ice, which is another mind-bending possibility for such a small world. Pluto's internal heat budget is limited compared to big planets, but it doesn't need to be huge to matter, because even a small, steady heat flow over billions of years can keep certain layers warm, especially if insulation is good, and if antifreeze-like compounds exist, and if the structure allows a liquid layer to persist beneath an icy shell. Even if you treat the ocean idea as uncertain, the surface still tells you Pluto isn't inert, because you see terrains that look young and terrains that look ancient right next to each other, implying resurfacing processes that operate unevenly across the globe. Some regions are heavily cratered, dark, old, a record of impacts from Kuiper Belt debris, while other regions are smoother and shaped, indicating more recent activity, and that contrast is part of Pluto's personality. It's both a memory surface and a living surface, depending on where you look. Pluto also has signs of glacial flow in the form of lobate features and valley-like movements where nitrogen ice appears to have flowed around obstacles and into basins, like slow rivers of pale ice navigating a landscape of water ice mountains. And the idea of a river on Pluto is already strange, but it's a river that moves over years and centuries, not days, carving and filling and smoothing in a time scale that feels like sleep itself. Pluto's atmosphere, though thin, adds softness. Haze layers can create a blue-tinted limb in certain lighting, and layered hazes can stack like atmospheric curtains, produced by photochemical reactions that build complex molecules which then condense into tiny particles, and those particles can settle onto the surface, contributing to Pluto's reddish-brown areas, often associated with tholins, complex organic substances formed by radiation-driven chemistry. These reddish areas are like dusting from the sky's chemistry lab, and over long time they can darken parts of the surface, absorbing more sunlight and changing local heating, which can influence where volatile ices prefer to accumulate. So chemistry, color, and climate become connected. Pluto's seasons are extreme not because it tilts a little, but because its orbit and tilt create long periods of varying sunlight, and its volatile ices respond by migrating, so whole surface regions can brighten or darken over time as frost moves, meaning Pluto's map is not fixed. It's a slow breathing pattern of frost deposition and sublimation. Then there's the Pluto-Charon system, which feels like a quiet gravitational duet rather than a planet with a moon, because Charon is large relative to Pluto, so the center of mass of the pair lies outside Pluto itself, meaning Pluto and Charon orbit a point in space between them, effectively a binary system, and they are tidally locked to each other, always showing the same face, like two bodies frozen into a mutual stare while they travel together around the sun. That binary relationship matters because it can influence tides and internal stress, and it shapes how you imagine the sky from Pluto. Charon would hang in the same position, massive and close, a steady presence that never rises or sets, while the sun would be a bright star-like disk rather than a blazing sun, and the distant planets would be tiny points, emphasizing how isolated Pluto is. Pluto also has smaller moons, Styx, Nix, Kerberos, Hydra, tiny irregular companions that likely formed from debris after a giant impact event that also created Charon, which implies Pluto's history includes violence, a collision energetic enough to reshape the system. And yet the result is a calm binary pair traveling in silence, like chaos turned into stable orbit. That impact origin idea is part of what makes Pluto feel complete. It has a story of formation and aftermath, not just a static existence. Pluto's classification change, the shift from planet to dwarf planet, was never really about Pluto being less interesting. It was about how we define categories when we discover many similar bodies beyond Neptune. But Pluto's real significance is that it became the first Kuiper Belt world we saw up close, a representative of a whole population, and it surprised us by being complex, meaning the outer solar system isn't a graveyard. It's a set of worlds with slow geology and seasonal atmospheres. Pluto's landscape includes basins, plains, mountains, and perhaps cryovolcanic-like features, places where material may have erupted as slushy water-ammonia mixtures or other cryogenic lava, reshaping the surface. And even the possibility is enough to change your intuition. Eruptions on Pluto wouldn't be fire. They'd be cold fluid spreading and freezing, building domes and flows, a kind of volcanism that looks like geology but runs at freezing temperatures. Impact craters also matter because they tell you where the surface is old, and the scarcity of craters on certain plains suggests resurfacing on geologically recent timescales, which means Pluto has had enough internal or surface-driven processes to erase scars, not everywhere, but in key regions. And the climate is tied tightly to those volatiles. Nitrogen dominates the atmosphere when it exists. Methane is present and affects haze formation and surface frost. Carbon monoxide plays a role, and the balance between them depends on temperature and sunlight. So Pluto's atmosphere is basically a seasonal equilibrium between surface ice and gas. And that equilibrium can shift as Pluto's distance changes, making the atmosphere thicken or thin over decades. If you want the calmest, accurate image, imagine Pluto at twilight. The sky is not thick, but it isn't empty either, with faint haze layers creating a soft gradient above the horizon, the sun small and bright like a distant lamp. The ground a mix of pale nitrogen ice plains with polygonal cells, rugged water ice mountains rising like stone, darker reddish regions dusted by atmospheric chemistry, and far above, Charon hanging motionless in the same spot, a grey companion that never leaves, while everything is still and cold and slow. The physics of Pluto is slow motion but not lifeless. Glaciers creep, frost migrates, atmospheres breathe, hazes form, tectonic cracks stretch, impacts scar and time erases, and the entire world continues moving through the Kuiper Belt in a long, tilted orbit that takes nearly 2.5 centuries, which is exactly why it's perfect as sleep material, because Pluto forces you to adopt Pluto time. Not hours, not days, not even years, but decades and centuries, where change is real but gentle, where the planet doesn't rush, where the sky can vanish and return, where ice flows like a calm liquid over a lifetime, and where being far from the sun doesn't mean being dead. It just means everything happens in quiet, patient cycles until your thoughts finally slow enough to match it. Pluto's climate is the cleanest example of how a world can have weather without having what you'd normally call a stable sky. because Pluto's atmosphere is basically a seasonal agreement between sunlight, temperature, and volatile ices, and the deal can change so much that the atmosphere can thicken, thin, and even partially collapse depending on where Pluto is in its long orbit, meaning Pluto doesn't have an atmosphere the way Earth does, it has an atmosphere the way a breath works, present, then reduced, then present again, tied directly to surface ice that can turn into gas and back into frost. The engine behind all of it is distance and time. Pluto takes about 248 Earth years to go around the Sun, and its orbit is eccentric, so its distance changes significantly over that long year, and its axis is tilted, so sunlight falls differently across latitudes over decades, creating extreme seasons that last longer than a human lifetime. And because sunlight is weak out, small changes in heating can decide whether nitrogen ice stays frozen or sublimates, and nitrogen is the main player because it's one of Pluto's most volatile surface materials, meaning it is eager to become gas when warmed even slightly. When Pluto warms, nitrogen ice sublimates and builds a thin nitrogen atmosphere, and methane and carbon monoxide are mixed in, influencing chemistry and temperature structure, and once you have even a thin atmosphere, it can transport heat and material, and it can form haze, because sunlight and energetic particles can drive photochemistry, breaking apart methane and building more complex hydrocarbons that can coagulate into tiny haze particles, creating layered hazes in the upper atmosphere that can stack like faint curtains, and those hazes can settle down to the surface over time, dusting parts of Pluto in reddish-brown material that darkens the surface and changes how it absorbs sunlight. That's the feedback loop. Sunlight warms ice. Nitrogen becomes gas. Atmosphere forms. Chemistry creates haze. Haze deposits dark material. Dark regions absorb more heat. Volatile distribution shifts. And because Pluto's surface is patchy, this feedback doesn't happen evenly. Some areas become cold traps where volatiles accumulate and stay, while other areas lose frost and become darker. A cold trap on Pluto is basically a basin or region where temperatures stay low enough that nitrogen, methane, or carbon monoxide prefer to freeze out. So over time, volatiles migrate and pile up there. And Pluto's bright heart-shaped region is the ultimate cold trap signature, a huge basin-like plain dominated by nitrogen ice that appears to be a major reservoir for Pluto's volatile budget, meaning it's not just a pretty shape, it's a climate anchor, a place that can store and release atmospheric material depending on season. On Pluto, ice is not just ground, it's climate infrastructure. The surface literally holds the atmosphere in frozen form, then releases it, then takes it back, which means the boundary between surface and air is blurry in a way Earth people don't naturally feel. The atmospheric pressure is tiny compared to Earth, but it can still matter because even a thin atmosphere can create frost patterns, transport haze, and influence temperature gradients. And the existence of haze layers also tells you the atmosphere has structure, temperature inversions, stratification, and chemistry that can produce distinct layers rather than a single uniform gas. The blue sky you can see in some Pluto imagery isn't a thick sky, it's scattering by haze particles along the limb, and that's a beautiful detail because it shows that even at the edge of the solar system, sunlight and chemistry can build a soft atmospheric glow, turning a world people imagined as a dead dot into a place with a horizon and a sky. Pluto's seasonal cycle likely involves nitrogen, condensing onto the surface in winter-like regions and sublimating in summer-like regions, and because Pluto's seasons are so long, the migration is slow and massive. Over decades, volatiles can shift from one hemisphere to another, changing brightness patterns and possibly redistributing surface frosts, meaning Pluto's map is not permanent, it's seasonal art that gets redrawn on century timescales. Methane behaves a bit differently because it's less volatile than nitrogen at Pluto temperatures, so methane can remain as frost even when nitrogen is more mobile, and methane frost can form patches and deposits that affect albedo and temperature. And because methane is a key ingredient for haze production, regions with methane involvement can indirectly influence haze chemistry and deposition. Carbon monoxide, also volatile, participates in the ice-gas equilibrium and can be a tracer of how volatiles move, and the combination of nitrogen-dominated atmosphere with methane and CO is a unique chemical signature that creates a climate unlike any planet you know. A climate where the main atmospheric gas is literally the main surface ice, and the atmosphere is fed by slow sublimation instead of by ocean evaporation, and where the weather is the slow rearrangement of frost rather than daily storms. Despite the thinness, Pluto's atmosphere can produce winds, especially driven by pressure gradients that form when sunlight heats one region more than another, and even gentle winds over long time can transport haze particles and influence how frost deposits, creating subtle patterns. Pluto's low gravity makes it easier for gas molecules to escape to space over long time, which means Pluto is slowly losing atmosphere material, but the atmosphere persists because the surface acts as a reservoir, replenishing it when conditions allow. So Pluto is in a long-term balancing act between escape and replenishment. The volatility cycle also connects directly to geology, because nitrogen ice can flow like a soft solid over time, meaning places where nitrogen accumulates are not just climate zones, they are moving landscapes, glaciers, and convection cells. So the climate doesn't only paint the surface, it reshapes it. And this is why Pluto's bright plains can look young and smooth. The nitrogen ice is actively overturning and flowing, erasing impact scars and smoothing texture, which is the physical counterpart to atmospheric breathing. When nitrogen is abundant on the surface, it becomes both climate fuel and geological material. A basin full of nitrogen ice can convect if warmed slightly from below, creating polygonal cell patterns where warmer ice rises and cooler ice sinks, and that convection can keep the surface refreshed, meaning Pluto's climate reservoir can also be Pluto's resurfacing mechanism. The long seasons also mean the same region can spend decades as a cold trap and then decades as a source, storing volatile ice and then releasing it so Pluto can shift which hemisphere is bright and frosted over time, and those shifts can influence where glaciers flow and where plains remain active. The binary relationship with Charon adds a quiet environmental detail too. Because Pluto and Charon are tidally locked, Charon hangs in the same place in Pluto's sky, a constant presence that can slightly influence tides and internal stress, but also a constant moonlight source in the sense of illumination and sky scenery, while the sun remains a bright, star-like disk that moves slowly across the sky, and the long day rhythm of Pluto is slower than Earth's, reinforcing that sense of time stretched out. If you want a calm mental scene that includes the climate truth, picture Pluto at a time when the atmosphere is present. The sun low, small but sharp, the horizon edged with faint blue haze created by tiny particles that scatter light, layered hazes stacked above the surface like delicate veils, the ground covered in pale nitrogen plains where the surface shows polygonal convection cells, nearby water ice mountains rising like dark rock, and darker reddish regions dusted by haze fallout, with frost patches bright in shaded basins where volatiles settle. Then imagine decades passing in silence, and the same plain gradually changing as sunlight angle shifts, nitrogen migrating, atmosphere thickening slightly, then thinning, then freezing out, the sky growing clearer as gases condense, the surface becoming more frosted in cold regions, then losing frost in warmer regions, all so slow that you can't feel it moment to moment, only in the idea that the world is breathing. Pluto's climate is not storms and rain, it's sublimation and deposition, it's frost migration and atmospheric collapse, it's chemistry in thin air and haze settling like dust, and the reason it's perfect for sleep narration is that it forces your brain into Pluto time, long cycles, gentle change, no urgency, where the sky itself can come and go, and nothing has to happen quickly to be real. Pluto and Charon together are what you get when a planet and moon relationship stops being a simple hierarchy and becomes a partnership, because Charon is so large compared to Pluto that the two bodies orbit a point in space between them, rather than Charon just orbiting neatly around Pluto's center. And that single geometric fact changes the whole feeling of the system. It's not a small moon circling a dominant planet. It's a binary pair locked into mutual motion, two worlds traveling together through the Kuiper Belt like a double object, calm but inseparable. The likely origin story behind this pairing is a giant impact early in Pluto's history, where a collision between Pluto and another large Kuiper Belt body ejected debris into orbit, and that debris reassembled into Charon and the smaller moons, and whether you treat that as confirmed or simply the best-fitting explanation, the important idea is that Pluto's system was shaped by violence and then settled into extreme stability, because impacts can create chaos, but gravity can turn chaos into a clean orbit over time. Pluto and Charon are tidally locked to each other, meaning each always shows the same face to the other, like two dancers frozen into a permanent partner hold. And because of that, if you stood on Pluto, Charon would hang in nearly the same spot in the sky all the time, never rising, never setting, just drifting slightly with orbital libration, a constant grey companion dominating the sky's composition, while the sun would move slowly as a bright, small disk, making the whole scene feel like a minimalist painting. Faint sky, cold horizon, and one large nearby world fixed overhead. That constant presence is more than aesthetic. Tidal locking implies that tidal energy was dissipated over time, heating interiors in the past and reshaping rotation rates, and even after locking, tides can still exist depending on orbital eccentricity, and those tides can contribute to internal stress, which matters because internal stress and heat connect to the possibility of subsurface oceans or cryogenic geological activity. Charon itself is not just a moon, it's a world with its own geology, with evidence of tectonic features and surface variation that suggest it has experienced internal evolution, possibly tied to freezing and expansion if it once had an internal ocean or warm layer that later cooled, because when water freezes, it expands, and expansion can crack and stretch a crust, creating long fractures and scarps, which fits the broader pattern seen in many icy bodies where internal cooling leaves tectonic fingerprints. Charon's surface is dominated by water ice and darker materials, and it lacks the same kind of volatile nitrogen-driven climate Pluto has, which is another important contrast. Pluto is a volatile world that breathes with nitrogen and methane frosts, while Charon is more like a bedrock ice world, colder and less volatile, meaning the two bodies share an orbit, but not a climate personality. Pluto's smaller moons, Styx, Nix, Kerberos, Hydra, are tiny compared to Pluto and Charon, but they're valuable because they look like relic fragments of that impact debris, and their existence supports the idea that the system formed from a debris disk that coalesced into a few small bodies, rather than one big one alone. These little moons are irregular, bright in places, and their rotations can be chaotic or unusual, which is a neat consequence of low gravity, complex formation, and weak tidal damping at their distances. And it adds to the feeling that Pluto's neighborhood is a lightly held collection of objects in quiet motion rather than a tight, disciplined satellite system like the inner planet's moons. The orbital dance between Pluto and Charon is also extreme in scale relative to Pluto. Charon orbits close enough that from Pluto it would appear enormous, and because they are locked, the sky scene is constant, reinforcing the sleep story feeling of steadiness, like the system is built around repetition. The same face, the same position, the same slow orbit. The binary nature also affects how you imagine gravity near Pluto, Because the gravitational environment isn't dominated by a single central mass at the center of Pluto, it's influenced by two large bodies, which can create regions where gravitational forces balance and where small particles could, in theory, linger. And while Pluto doesn't have rings like Saturn, the concept that the system's gravity is two-body-shaped adds depth to the mental picture. The space between Pluto and Charon is not empty emptiness. It's a region where gravity is shared, where trajectories curve around a combined center. If you zoom out, the entire Pluto-Charon pair travels together through the Kuiper Belt in a long, eccentric, tilted orbit around the Sun, and they're mutual. Locking means that while they orbit the Sun, they also keep their own internal rhythm, one turning around the other in a steady loop, like a clock inside a clock. And because Pluto's year is so long, the background of sunlight changes slowly over decades, so the system experiences long seasons while the binary pair maintains constant local geometry, meaning Pluto's surface climate can shift while Charon remains fixed in the sky, a constant companion through century-long winters and summers. This contrast is the soft emotional core of the Pluto-Charon story. Far from the Sun, with light weak and time stretched, Pluto is still active. Its volatiles migrate, its atmosphere can appear and fade, its nitrogen ice can flow, and through all of it Charon stays there, unblinking, making Pluto feel less lonely and more like part of a paired existence. The calmest image to carry is standing on the edge of Pluto's bright nitrogen plain, the ground pale and textured with slow convective polygons, dark water ice mountains rising nearby like stone, a thin haze giving the sky a faint gradient when the atmosphere is present. And above it all, Charon hanging in the same place, a large grey disk with subtle contrast, while the sun sits low and sharp and distant, and nothing moves quickly. Only the idea that everything is moving, orbiting, locked into rhythm, the binary system turning in silence through the Kuiper Belt, while the surface slowly changes in cycles that don't care about human time. Pluto's geology is the part that embarrasses every old assumption people used to make about small, cold worlds. Because if Pluto were just a dead, icy rock, it would be uniformly cratered, uniformly ancient, and basically unchanged for billions of years. But instead, it's a mosaic of young and old terrains, flow features, mountains, plains, fractures, and resurfaced regions that prove Pluto has had enough energy, internal, seasonal, or both, to keep moving material around, and rewriting its surface in certain places. And the calm way to see it is to treat Pluto like an ice and rock planet, where the soft materials are exotic volatiles that behave like glaciers, and the hard material is water ice that behaves like bedrock. One of the cleanest pieces of evidence for activity is the bright, smooth, nitrogen ice plain in Pluto's heart region, because a smooth surface with very few impact craters implies resurfacing. And on Pluto, the resurfacing mechanism can be simple and elegant. Nitrogen ice can flow and overturn. At Pluto's temperatures, nitrogen ice can be soft enough to behave like a viscous solid, creeping over time like a glacier, and if a thick layer of nitrogen ice is warmed slightly from below by internal heat or by absorbed sunlight, it can convect. Warmer nitrogen ice rising, cooler nitrogen ice sinking, creating large polygonal cells that can refresh the surface by overturning and erasing craters, and those cell patterns are consistent with what's seen on Pluto's plains, giving you a literal visual texture of slow motion hidden under a frozen skin. Glacial flow features show up elsewhere too, where nitrogen ice appears to have moved around obstacles and into basins, producing lobate margins and valley-filling patterns that look like ice rivers frozen mid-crawl. And the key mental twist is that these glaciers are not water glaciers, they're nitrogen glaciers, while water ice is what forms the rigid mountains. Those mountains are another shock. Pluto has rugged ranges made of water ice that can stand tall, because water ice is strong at Pluto's temperatures, acting like rock, And the existence of mountains implies that Pluto's crust can support significant relief, and that tectonic or resurfacing processes have exposed or uplifted that strong material. Pluto's surface also shows large fractures and scarps, features that resemble tectonic stretching, suggesting the crust has been pulled apart in places, and a plausible driver for that kind of extensional tectonics is internal evolution, especially the freezing of a subsurface ocean. If Pluto once had or still has a layer of liquid water beneath its crust, gradual freezing would expand volume and push outward, stressing the crust and creating cracks and faults. And even if the ocean is partly frozen now, the cracks could remain as the preserved fingerprint of that expansion. There are also regions of chaotic terrain where the surface looks disrupted, broken, and jumbled, which could reflect localized melting, collapse, or mobilization of material in a way that doesn't require Earth-like volcanism, because on Pluto, volcanism would be cryovolcanism, cold eruptions of slushy water-ammonia mixtures or other cryogenic fluids that can flow and then freeze, building domes and smooth deposits. And while the exact interpretation of every feature is debated, the broader idea holds. Pluto has multiple candidate processes that can renew terrain, including glacial flow of volatiles, convective overturn in nitrogen ice plains, tectonic cracking from internal expansion, and possible cryovolcanic emplacement. Impact craters help you map what's old and what's young, because heavily cratered regions are like memory surfaces preserved for eons, while smoother regions are like reset surfaces, and Pluto has both side by side, meaning its activity is not global and uniform but selective, tied to where volatiles collect, where basins concentrate ice, where internal heat can be focused, and where mechanical stresses open pathways for movement. The volatile cycle and geology are inseparable because Pluto's climate moves nitrogen and methane frosts around the planet over long seasons, building thick deposits in cold traps and removing them in warmer regions, and those thick deposits are exactly what can flow and convect. So the climate doesn't just paint Pluto brighter or darker, it supplies the raw material for glaciers and resurfacing, turning seasonal frost migration into geological motion. And that's why Pluto's bright heart is both a climate reservoir and a geological engine. Albedo feedback can amplify this. Bright ice reflects sunlight and stays colder, helping it persist, while dark haze deposits absorb sunlight and warm surfaces, encouraging volatiles to migrate away so the planet naturally separates into bright, cold, volatile-rich regions and darker, warmer regions, and that separation helps maintain the contrast between active nitrogen plains and older, darker terrains. Water ice bedrock shapes how volatile ices move, creating topographic barriers that guide nitrogen glaciers like mountains guide rivers, and you can imagine nitrogen ice creeping along the edges of ranges, pooling in basins, and slowly filling low regions over decades and centuries. Pluto's low gravity also shapes the feel of its landscapes. Slopes behave differently, glaciers might flow with different dynamics, and impacts can eject material differently, but gravity is still strong enough to create real mountains and basins, so the terrain has weight even though the world is small. One of the most calming ways to picture Pluto's geology is to imagine standing at the boundary between old and new. Behind you, heavily cratered dark terrain, ancient and scarred. Ahead of you, a smooth, bright nitrogen plain patterned with huge polygonal cells that look like cracked ice, but are actually convection features. And between them, water ice mountains rising like black stone, while the sky is thin and faintly hazy when the atmosphere is present, and the sun is a small, bright disk far away. The deeper truth is that Pluto's geology is slow, but it's not subtle. Its features are dramatic. They're just produced by processes that operate at Pluto speed, glaciers that creep over lifetimes, convection that overturns plains over thousands of years, tectonic stresses that build and crack over millions of years, and climate cycles that migrate frost over decades so the planet can change without ever looking busy. And that's why it works for sleep narration. Pluto is a world where motion exists without urgency, where ice behaves like rock and rock is hidden under ice, where landscapes are shaped by freezing and sublimation instead of rain and rivers, and where even at the edge of the solar system, the surface can still be renewed, quietly, patiently, until your own thoughts learn the same trick and drift into stillness. Pluto's story is inseparable from the Kuiper Belt, because Pluto isn't a weird, lone exception hiding beyond Neptune. It's the first well-known face of a whole population of icy bodies that live in the solar system's outer archive. And once you see Pluto as a Kuiper Belt world instead of a demoted planet, everything about it makes more sense. Its composition, its orbit, its binary relationship with Charon, its volatile ices, and even the reasons it surprised us. The Kuiper Belt is a region beyond Neptune, filled with objects left over from early solar system formation, bodies that never merged into a planet because Neptune's gravity and the solar system's evolution prevented clean accretion out there, leaving a disk of icy remnants that range from small chunks to large dwarf planets. And Pluto is one of the largest members of that population, which means Pluto is both representative and special. Representative because it shares key traits with many outer bodies, special because it's big enough to be geologically complex and to hold volatiles in ways smaller bodies can't. Pluto's orbit is tilted and eccentric, and it's in a resonance with Neptune that keeps it stable. Pluto and Neptune move in a rhythm that prevents close encounters, even though their paths overlap in a simplified diagram, meaning Pluto's weird orbit isn't unstable chaos. It's a locked pattern, a gravitational agreement enforced by resonance, and that resonance is another example of outer solar system order, repeated gravitational timing creating long-term stability. Pluto also belongs to a subgroup often called Plutinos, objects in the same resonance, showing that Pluto's orbit is part of a broader resonant structure in the Kuiper Belt, not a one-off. The significance of that is soothing because it's a reminder that even at the edge of the solar system, motion can be disciplined. Objects repeat patterns, avoid collisions, and maintain stable rhythms over billions of years, not because they choose to, but because gravity writes repeating constraints into their paths. The Kuiper Belt itself isn't uniform, it's structured, with a classical belt of objects in relatively low eccentricity orbits and resonant populations shaped by Neptune's migration early in solar system history. And Pluto's existence within these structures hints that the outer solar system didn't form in place and stay. Still, Neptune likely moved outward, scattering and capturing objects into resonances, and that migration rearranged the belt, populating it with different dynamical classes, meaning Pluto's current orbit is partly a fossil of that ancient reshuffling. This is why the Kuiper Belt feels like an archive. It contains relics of the solar system's early architecture changes, with orbits that preserve evidence of how giant planets moved and how material was redistributed. Pluto's physical traits fit the Kuiper Belt environment too. It's rich in volatile ices like nitrogen and methane because temperatures are low enough for those materials to exist on the surface, and it can hold them because it's large enough and cold enough, while many smaller Kuiper Belt objects may have lost the most volatile ices or never accumulated them in large quantities. And this helps explain why Pluto can have a seasonal atmosphere while many smaller bodies cannot. The Kuiper Belt context also clarifies the classification shift that people get emotional about. When astronomers discovered many similarly sized icy worlds beyond Neptune, it became clear that calling Pluto a planet, while not calling the others planets, was a definitional mess. So the category dwarf planet is essentially a way of acknowledging that Pluto is one of the largest members of a population rather than one of a small set of dominant bodies that cleared their neighborhoods. But that label does not reduce Pluto's complexity. It simply places it correctly in a broader family. If anything, the Kuiper Belt lens makes Pluto more interesting because it makes Pluto a gateway. By understanding Pluto, you get clues about the chemistry, geology, and orbital dynamics of dozens or hundreds of similar worlds, some of which may also have surprising activity. Pluto's surface processes, nitrogen glaciers, convective plains, haze chemistry, are likely not unique in principle. They're the kind of thing that can happen on a volatile rich body with enough size and internal heat, suggesting that other large Kuiper Belt objects could host their own versions of slow geology and seasonal cycles. Pluto's binary with Charon also fits Kuiper Belt collision history. Impacts and mergers were more common in the early solar system when debris was abundant, and a giant impact forming a binary pair is plausible in that environment. And the existence of other binaries in the Kuiper Belt supports the idea that paired objects can form and persist out there, meaning Pluto-Charon is the most famous binary, not the only binary pattern. The Kuiper Belt is also where you see extremes of reflectivity and color. Some objects are dark and red from radiation-processed organics, some are bright from fresh ice, and many show a reddish hue thought to come from complex organic substances produced by radiation-driven chemistry in cold conditions. So Pluto's reddish regions and haze deposits fit a regional theme: sunlight and cosmic radiation working slowly on hydrocarbons and nitrogen compounds to create tholins and other complex materials that stain surfaces over time. The outer solar system's radiation environment and low temperatures turn chemistry into a slow paintbrush, producing surface colors and coatings that can persist, while impacts and occasional resurfacing can refresh areas, creating patchwork appearances, which is exactly what Pluto shows. Bright, renewed plains next to dark, ancient terrain. Another key Kuiper Belt idea is that impacts out there are slower on average, but still significant, and craters on Pluto and other bodies record a long history of collisions. But resurfacing can erase some craters, so crater counts become a way to measure surface age and activity level, and Pluto's mix of cratered and smooth surfaces is again consistent with a Kuiper Belt world that is not uniformly dead. If you zoom further out, Pluto's existence also reframes the solar system's edge. The solar system doesn't end at Neptune, it continues into a disk of objects, then beyond that into even more distant populations, and Pluto is the symbol of that continuation, a reminder that the outer regions are populated and structured, not empty. The calm mental scene to hold is Pluto moving through the Kuiper Belt like a slow ship in a cold, dark sea, with other Kuiper Belt objects scattered across vast distances like distant islands, each on its own orbit, some locked in resonances, some in more circular paths, all quietly repeating their routes over centuries, while Neptune acts like the distant giant that shaped the whole region by migration and resonance capture, and the sun is just a bright star providing weak but still meaningful light. In that scene, Pluto isn't lonely. It's embedded, part of a family, and that family is important because it changes the emotional interpretation. Pluto wasn't taken away, it was placed correctly, and once it's placed correctly, you can appreciate it as what it is: a volatile, rich, geologically active Kuiper Belt dwarf planet, with a binary companion, seasonal atmosphere, and a surface that rewrites itself in slow motion. One world among many, but still one of the best examples we have of how alive the outer solar system can be when you stop expecting it to behave like the inner planets. Pluto is one of the best worlds for quiet scale, because it forces you to accept that small doesn't mean simple, far doesn't mean frozen forever, and slow doesn't mean dead. And the way to really feel Pluto is to stop picturing it as a lonely dot, and instead picture it as a working system of cycles, volatile ice cycling between ground and sky, glaciers creeping like time itself, haze chemistry building and settling, a binary companion fixed in the sky, and an orbit so long it stretches your sense of what a season even is. Pluto's seasons aren't cute variations, they are decades-long reorganizations of sunlight, temperature, and frost distribution, because Pluto's axis is tilted and its orbit is eccentric, so the amount of sunlight a hemisphere gets can change dramatically over time. And since Pluto's surface includes nitrogen, methane, and carbon monoxide ices that respond strongly to small temperature changes, the seasonal forcing isn't cosmetic. It can decide whether the atmosphere exists at a given pressure level or collapses into frozen frost on the ground. When Pluto warms as it approaches closer parts of its orbit, or when certain latitudes receive more sunlight, nitrogen ice sublimates and creates a thin nitrogen atmosphere, and that atmosphere can carry methane and CO, forming layers, gradients, and hazes. And when the world cools, the atmosphere partially freezes out and pressure drops, meaning Pluto can literally inhale and exhale over decades as surface ice turns to gas and back to ice. The atmosphere is thin, but it's still structured, and one of the most important details is haze. Sunlight and energetic particles can break apart methane and create more complex hydrocarbons that condense into tiny particles, forming layered haze strata in the upper atmosphere. And those layers matter because they create the soft limb glow, and they act like a slow rain of chemistry, settling onto the surface as reddish-brown. Organics that can darken regions, and darkening changes heating, and heating changes volatile stability. So haze deposition becomes climate feedback, gradually influencing where frosts accumulate and where they retreat. Pluto's surface and climate are welded together because the surface is the reservoir for the atmosphere. There is no ocean feeding air, there's ice feeding air, so you can't separate meteorology from geology, because if nitrogen ice piles up in a basin, that basin becomes both a climate cold trap and a geological engine, since thick nitrogen deposits can flow, convect, and erase craters, which is likely why Pluto's bright heart region includes a large, smooth, nitrogen ice plain that looks young and actively refreshed. That nitrogen plain behaves like a slow-moving glacier field with convection cells, where warmer ice rises and cooler ice sinks, creating polygonal patterns and continually resurfacing the top layer, which not only keeps it bright, but also keeps it young in crater terms, meaning climate-driven volatile deposition can produce geological youth. Water ice, meanwhile, acts as bedrock on Pluto, because at those temperatures it's rigid and strong, so Pluto's mountains are water ice mountains, rock-like in behavior, standing above softer volatile plains. And this reversal of intuition is a big reason Pluto feels alien. What you'd call ice on Earth is stone there, and what you'd call gas on Earth is ground there, shifting your whole material sense. Pluto's tectonic features, fractures, scarps, and stretched terrains, hint that internal evolution has also played a role, possibly through the freezing of a subsurface ocean, because freezing expansion can create extensional stress and crack a crust. And whether Pluto still has a liquid layer or not, the tectonic signatures suggest the interior has changed and pushed on the shell over long time. Pluto's binary relationship with Charon adds steadiness to the sky. Because they are tidally locked, Charon hangs in nearly the same spot, a constant companion that never rises or sets, and that constant presence makes Pluto's world feel anchored, even as seasons change and atmospheres breathe, because the local sky geometry stays the same while the climate cycles shift. The smaller moons orbit farther out like tiny fragments, likely impact debris relics, reinforcing that Pluto's calm present was built from an ancient collision that settled into stable rhythm. The Kuiper Belt context matters too, because Pluto isn't isolated. It's a member of a broader population shaped by Neptune's resonances and the solar system's early migration, and Pluto's orbit is stable partly because it's locked in resonance with Neptune, meaning Pluto's path is not random, it's disciplined by repeating gravitational timing, and that discipline is another theme of Pluto: repetition over urgency. Even Pluto's classification story is just another example of humans trying to draw clean lines on messy families. Because Pluto is a dwarf planet, not because it's unimportant, but because it's one of the largest members of a population of outer icy worlds. And in that sense, Pluto became the ambassador, the first one we saw up close, the one that forced us to admit that the outer solar system has worlds with real geology and seasonal atmospheres. The calmest mental picture that ties everything together is Pluto at twilight, with the atmosphere present. A thin sky with layered haze, the sun small and sharp like a bright star. The horizon, a pale nitrogen plain with convection polygons. Dark water ice mountains rising nearby like jagged rock, reddish regions dusted by haze fallout, frost patches bright in shaded basins, and overhead Charon fixed like a grey coin, while nothing moves fast. Only the concept of motion exists, the slow creep of nitrogen glaciers, the slow migration of frost over decades, the slow settling of haze particles like chemical snow, and the slow orbit of the binary pair through the Kuiper Belt in a year longer than most human history. Pluto is a world where time is the main landscape feature, and once you let Pluto time into your head, century seasons, glacier motion on lifetime scales, atmosphere breathing over decades, your own thoughts feel out of place when they try to sprint, because Pluto doesn't sprint, it cycles, and if you match that, you stop needing an ending. You stop needing to solve anything right now, and you can just let the quiet repetition do what it always does out there. Keep going without you until you fall asleep. Pluto is a world where the active processes are slow enough to feel like stillness, but they're real. And the only reason people ever assumed Pluto would be dead is because they were trapped in the inner solar system mindset, where activity means heat, and heat means closeness to the sun. But Pluto rewrites that rule by showing that you can get motion from a different mix: volatile chemistry on the surface, long-seasoned sunlight changes, and just enough internal heat to keep certain materials mobile. So Pluto becomes a planet-sized example of quiet physics doing work over long time. Start with the surface inventory because that's Pluto's main engine. Nitrogen, methane, and carbon monoxide ices sitting on a crust where water ice is essentially bedrock. And this single fact flips your intuition. Water ice behaves like rock at Pluto temperatures, nitrogen behaves like a glacier fluid, methane behaves like a frost that can persist and seed chemistry, and CO tags along as another volatile that participates in equilibrium. So Pluto's geology is partly a story of which ices can move and which can stand. The biggest climate geology anchor is that bright heart region, especially the large nitrogen ice plain that looks young because it has few craters. And the reason it can look young is not magic. It's a resurfacing mechanism that doesn't need molten rock. Thick nitrogen ice can flow and overturn. If you picture a basin filled with nitrogen ice, warmed slightly from below by internal heat and from above by absorbed sunlight, it can convect, and convection in a viscous solid can produce polygonal cells where warmer material rises, cooler material sinks, and the surface gets recycled, which erases craters and refreshes texture. So the plain becomes a self-renewing surface, and the visible polygons become the signature of a slow overturning process happening under a frozen skin. That plain is also a massive reservoir for Pluto's volatile budget, meaning it's not only a geological feature, it's a climate battery. When conditions favor sublimation, nitrogen leaves the plain and builds the atmosphere. When conditions favor condensation, nitrogen returns and freezes out, thickening the deposit. So the same place that holds the volatile inventory also moves it and reshapes itself, turning climate into geology. Pluto's seasons are not minor because Pluto's year is about 248 Earth years, its orbit is eccentric, and its axis is tilted. so sunlight shifts across hemispheres on decade time scales, and because the volatile ices are so sensitive, those shifts can decide whether Pluto's atmosphere is thicker or thinner, or how much of it freezes onto the ground, making the atmosphere partially seasonal and partially migratory. The atmosphere is mostly nitrogen when it exists, with methane and CO mixed in. And it's thin, but thin doesn't mean unimportant. Thin air can still transport heat, form haze layers, and mediate sublimation and condensation. Pluto's haze is one of the most underrated details because it proves an active photochemical pipeline. Sunlight and energetic particles break apart methane, build more complex hydrocarbons, and those products condense into tiny particles that stack into layered hazes in the upper atmosphere, like faint curtains, then settle onto the surface as reddish-brown organics, slowly staining some regions and altering their reflectivity. And reflectivity is not cosmetic on Pluto, it's control. Bright ice reflects sunlight and stays colder, helping it persist as a cold trap, while dark deposits absorb more heat, encouraging volatiles to migrate away, so Pluto naturally sorts itself into bright, cold, volatile-rich zones and darker, warmer zones, which reinforces where nitrogen collects and where it retreats. This is why the surface looks like a patchwork. Some areas are bright and young-looking because volatiles are active and renewing them. Other areas are dark and heavily cratered because they are not being resurfaced as strongly, functioning as memory surfaces that preserve ancient impacts. Pluto's mountains are the second shock because they are rugged, high-relief ranges made of water ice, which is rock there, and their existence implies Pluto's crust has strength and that tectonic or uplift processes have exposed water ice bedrock through or alongside volatile deposits. These mountains also act like topographic barriers that guide volatile glaciers. Nitrogen ice can creep around them, pile up against them, flow through gaps, and pool in basins like slow rivers navigating rock ranges, and that creates valley-filling and low-bolt glacial features that look familiar in shape but are alien in material. Pluto's tectonic features, long fractures, scarps, and stretched terrains, add an interior dimension because cracking a crust at planetary scale usually implies stress from within, and one plausible stress source is the freezing of a subsurface ocean. If Pluto had or has a liquid water layer beneath its ice shell, gradual freezing would expand volume and push outward, generating extensional stress and cracking the crust. And even if the ocean is partly or mostly frozen now, the tectonic scars can remain as fossils of that internal change. Radiogenic. Heating from radioactive elements in Pluto's rocky component can provide long-term internal heat, not enough for fire volcanism, but possibly enough to keep a liquid layer stable for long periods under thick insulation, especially if antifreeze-like compounds are present. So Pluto's interior doesn't need to be hot, it only needs to be warm enough for long enough to matter. That interior warmth, combined with the weight of ice and the pressure at depth, can support slow geological activity like cryovolcanism, eruptions of cold slurries rather than molten rock, where water ammonia mixtures or other cryogenic fluids could be emplaced on the surface and then freeze, building smooth deposits, domes, or flow-like forms. And while interpretations differ feature by feature, the bigger point is that Pluto has multiple ways to refresh itself: volatile ice flow and convection, tectonic extension, and possible cryovolcanic emplacement, all operating in slow motion. The heart-shaped basin itself may be impact-formed, a giant scar that became a climate and geology hub because a deep basin creates a cold trap and a place where volatiles can accumulate, and accumulation thickens nitrogen deposits. And thick deposits are the ones that can convect and flow, so an ancient impact can set up the conditions for long-term resurfacing, turning a violent origin into a persistent renewing engine. Some hypotheses even suggest that loading from a massive volatile deposit can influence Pluto's orientation over time, because when you put a huge mass anomaly on a rotating body, the system may tend to reorient so that anomaly moves toward an energetically favorable position, a process called true polar wander, which would mean the placement of Pluto's bright basin might not be random relative to its spin axis, but part of a slow adjustment driven by mass distribution, again turning surface and interior into a coupled system. Pluto's atmosphere adds another layer of quiet dynamics. Because Pluto's gravity is low, atmospheric molecules can escape to space more easily over long time, and the atmosphere also interacts with the solar wind, meaning Pluto is not perfectly sealed off. It's slowly losing material, yet it can maintain an atmosphere seasonally because the surface ice reservoir can replenish it. So Pluto lives in a balancing act between loss and resupply, with the surface acting like a bank account that gets deposited into the sky and then withdrawn back onto the ground. The atmosphere's vertical structure can include temperature inversions and layers that support haze stratification, and the limb glow seen at Pluto's horizon is a reminder that even thin haze can scatter sunlight into a soft gradient, producing a real sky aesthetic even at the edge of the solar system. Now add the Pluto-Charon relationship, because it changes how you feel the world. Charon is so large relative to Pluto that the barycenter lies outside Pluto, making them a binary pair rather than a simple planet-moon hierarchy, and they are tidally locked, so each shows the same face to the other, meaning if you stood on Pluto, Charon would hang in nearly the same spot forever, a constant grey companion that never rises or sets, while the sun, small but intense, moves slowly, and that constant sky geometry creates a steady psychological anchor in a landscape otherwise defined by long seasonal change. Charon itself contrasts with Pluto because it lacks the same volatile nitrogen-driven climate, being more of a water-ice bedrock world with its own tectonic history. And the smaller moons, tiny fragments likely from the same impact origin, add the sense of a system assembled from debris that later settled into quiet orbits. All of this sits inside the Kuiper Belt context, where Pluto is not a lone exile, but a representative of a whole population of icy bodies shaped by Neptune's resonances and early migration, and Pluto's orbit is stabilized by resonance, with Neptune, which is another example of the outer solar system being structured rather than chaotic, repeating gravitational timing, creating long-term safety from close encounters. The classification drama people cling to is basically irrelevant compared to what Pluto actually proved. The outer solar system is not a cemetery. It's a slow laboratory where volatiles migrate, atmospheres breathe, surfaces get processed by radiation chemistry, and geology can happen in cold forms. If you want to hold the calmest Pluto truth as you listen, it's that Pluto is defined by cycles that don't need speed. Nitrogen sublimates into air and freezes back down. Haze forms and settles like chemical snow. Dark deposits warm and push volatiles away, while bright deposits stay cold and hoard them. Glaciers creep around water-ice mountains. Convection overturns plains to erase craters. Tectonic fractures open as interiors evolve. A binary companion hangs fixed overhead, and the whole system drifts through deep space on a 248-year orbit. So the world is always changing but never rushing. And that's the sleep effect. Pluto forces your brain to drop the addiction to quick resolution, because Pluto doesn't do quick. Pluto does steady repetition on long time scales, where even an atmosphere can be seasonal and even ice can be a moving fluid. And once your mind accepts that rhythm, slow, patient, inevitable, your thoughts stop trying to sprint and start doing what Pluto does best: cycle gently until they fade into quiet. Pluto didn't become real to people until New Horizons, and that's the part that matters because before the flyby, Pluto was basically a rumor with a blurry personality, an orbit, a size estimate, a color hint, and a lot of confident assumptions that it would be boring. Then one spacecraft showed up for a few hours and exposed how fragile those assumptions were. because Pluto wasn't a dead crater ball, it was a structured world with young plains, mountains, haze layers, complex surface chemistry, and a binary companion that makes the whole system feel like a paired object moving through the Kuiper Belt. The flyby itself is a good reminder of how the outer solar system forces different kinds of exploration. You don't get casual revisits, you get one fast pass after a decade of travel, so the data you collect is precious and partial, and that partialness is why Pluto stays fascinating. There's enough detail to prove it's complex, but enough unknown left to keep the story open. New Horizons revealed the bright, heart-shaped region immediately. And the important thing about that heart isn't just aesthetics, it's how it acts like a climate and geology hub. The bright, nitrogen-rich plain inside it looks young because it lacks many craters, and its surface shows polygonal cell patterns consistent with convection in a thick, volatile ice layer, which is basically Pluto advertising that even in deep cold, materials can move if they're the right materials. The same imagery showed mountains that shouldn't exist on a dead ice rock, because rugged ranges require strong material to hold steep relief, and on Pluto that strong material is water ice acting like bedrock, meaning the landscape is built from a material role reversal. Nitrogen and methane are the mobile, soft stuff. Water ice is the rigid, hard stuff, and once you accept that, the whole planet becomes easier to read. Bright plains are volatile deposits and active resurfacing zones. Dark, cratered terrains are older regions coated by radiation-processed organics, and mountains are water ice crust exposed or uplifted. New Horizons also gave us the atmosphere's vibe in a way Earth brains instantly recognize as real planet, because Pluto had a visible limb with haze layers stacked like thin horizontal bands, a pale glow that looks almost delicate, and those haze layers imply chemistry and structure. Methane in the atmosphere being broken down by sunlight and energetic particles, building complex hydrocarbons that condense into haze particles, then settling out over time to stain parts of the surface reddish-brown, meaning Pluto has a chemical pipeline from air to ground, a slow rain of organics that can alter surface reflectivity and therefore affect where volatiles like nitrogen prefer to sit. And reflectivity isn't a small detail on Pluto, it's control. Bright regions stay colder and hold frosts. Dark regions absorb more heat and drive frosts away. So haze deposition can indirectly reshape climate by creating dark, warm zones and bright, cold zones that influence the volatile cycle. And that volatile cycle is basically Pluto's heartbeat. Nitrogen ice sublimating into atmosphere when warmed, then condensing back down when cooled, thickening and thinning the atmosphere seasonally over decades, because Pluto's year is about 248 Earth years, and its orbit is eccentric and tilted, so sunlight distribution changes dramatically on human timescales. New Horizons also sharpened the relationship with Charon in a way that matters beyond trivia. Pluto and Charon are tidally locked, and the barycenter lies outside Pluto, so the system is genuinely binary, and that changes how you imagine their long-term evolution, because tidal locking means energy was dissipated, spins were slowed, and the pair settled into a stable state, and it changes how you imagine the sky, because Charon would hang in essentially one place from Pluto's surface, never rising or setting, a constant grey companion through century-long seasons, which adds a strange, calm consistency to a world defined by slow climate change. Charon itself shows tectonic features and surface contrast that suggest it had internal evolution too, possibly tied to freezing and expansion if it once hosted a subsurface ocean or warm layer, leaving fractures and scarps as the crust adjusted. So the binary pair isn't active Pluto plus dead moon, it's two evolved worlds with different materials and different climate roles. New Horizons then pushed farther into the idea that Pluto is a representative of the Kuiper Belt rather than an outcast, because after Pluto it flew to a small Kuiper Belt object, and showed that even small bodies out there can have interesting shapes and histories, reinforcing the idea that the region is a population, an archive shaped by Neptune's migration and resonances, and Pluto is one of the largest members, big enough to keep volatiles and show geology, but still part of a family. The resonance with Neptune is another key detail that makes Pluto feel less random. Pluto's orbit is eccentric and tilted, but it's protected by resonance timing that prevents close encounters with Neptune, a gravitational choreography that repeats for billions of years, and that repeating choreography fits the sleep story feel. Out there, even weird orbits can be disciplined patterns rather than chaotic flukes. One of the most underrated results from New Horizons is how it turned distance into a sensory thing. The Sun is not a blazing presence on Pluto. It's a small, brilliant disk, like a star that still casts sharp shadows because there's little atmosphere to diffuse light, and that creates a visual mood where landscapes look crisp and cold with hard edges and long shadows, and that crispness makes the geology feel even more dramatic. Water ice mountains look like black stone, bright nitrogen plains look like frozen light, and dark areas look like dusted rust. The mission also forced people to stop treating crater counts like a guaranteed old everywhere assumption, because the contrast between cratered and smooth terrains means resurfacing is selective, tied to where volatiles accumulate and where internal heat or topographic basins concentrate activity. So Pluto is a patchwork world where some areas act as archives and some act as active surfaces, which is exactly what you'd expect on a planet where the main active materials are volatiles that don't cover everything uniformly, but migrate to cold traps and basins. And basins matter a lot because if the heart region sits in a deep basin, that basin becomes a climate cold trap, accumulating nitrogen ice, and thick nitrogen deposits are the ones that can convect and flow, meaning a single ancient impact could set the stage for long-term resurfacing by creating a place where volatiles pile up and keep the surface young, turning violence into renewal. There are even ideas that the placement of that basin and its massive ice load could influence Pluto's orientation over time through true polar wander, where a body reorients so a mass anomaly moves to a position that's energetically favorable relative to its rotation, which would mean surface mass distribution and spin geometry are coupled. Another deep system feedback that makes Pluto feel like more than surface frosting. New Horizons also raised the question of how Pluto loses atmosphere to space, because with low gravity and exposure to solar wind, atmospheric escape is inevitable over long time, and measuring or estimating escape rates matters because it tells you how quickly Pluto could lose volatiles if it weren't being replenished by surface reservoirs, and it forces a long-term story. Pluto is not sealed, it's slowly leaking, but it can still run a seasonal atmosphere because the surface stores nitrogen and methane as ice and releases them when conditions allow. So Pluto is in a long balancing act between loss and replenishment. That balancing act is another reason the atmosphere is so interesting. An atmosphere that can collapse partially and reform isn't a fragile failure. It's a dynamic equilibrium, and it makes the boundary between ground and sky feel thin. The sky is literally ground material that temporarily became gas. The haze is part of that. Same boundary because haze particles formed in the sky become surface coatings, changing albedo, changing heating, changing where frost goes, and frost controls how much atmosphere you get, so the sky feeds the ground, and the ground feeds the sky, and the whole system cycles on decade to century time scales. The best mental image for this is to imagine Pluto through a sequence. First, a period when Pluto is warmer and the atmosphere is more present, haze layers thickening, a faint gradient in the sky, nitrogen frost actively sublimating from sunlit areas and condensing in colder basins. Then a period as Pluto cools and the atmosphere thins, pressure dropping, nitrogen freezing out more strongly, the sky becoming clearer, the surface becoming brighter in cold regions. Then a later warming period where gases return, haze production resumes, and the surface begins its slow migration again. All of it happened so slowly that from moment to moment it looks static, but in the big picture, it's a world breathing. And New Horizons didn't just give us facts, it gave us an emotional correction. Pluto is not small, therefore simple, it's small, therefore different. Because on Pluto, the primary movers are not liquid water and silicate volcanism, they're volatile ices and slow thermal processes, and those processes can still produce young surfaces, mountains, tectonic fractures, and atmospheric chemistry, just on different timescales and with different materials. That's why Pluto is so good for sleep narration, because it's a world where the action is real, but the tempo is slow, where geology is not loud but persistent, where the sky is thin but layered, where a companion world hangs fixed in the same place, and where the entire system drifts through the Kuiper Belt on a 248-year orbit, carrying its slow cycles like a clock that doesn't care whether anyone is watching. And the last correction Pluto forces is about importance. Classification. Arguments are human bookkeeping, but Pluto's significance is that it opened the door to the Kuiper Belt as a set of real worlds, not dots, and it showed that the outer solar system can host landscapes that are alive in their own cold way. Glaciers made of nitrogen, mountains made of water ice, haze that falls like chemistry snow, an atmosphere that can appear and fade, and a binary dance with Charon that stays locked and steady. So if you let that scene sit in your head long enough, your own thoughts start doing what Pluto does, slowing down, cycling gently, and eventually fading into quiet. Pluto's materials are the real plot twist, because the moment you stop thinking in Earth materials and start thinking in Pluto materials, the whole planet becomes readable. Water ice is rock, nitrogen ice is a moving fluid, methane is both frost and chemical feedstock, carbon monoxide is a volatile participant, and sunlight is weak but still powerful enough to drive cycles. Because the relevant substances respond to small temperature shifts, so Pluto becomes a world where chemistry, climate, and geology are welded together by the fact that the atmosphere is basically the surface in gas form. Start with the temperature reality. Out at Pluto's distance, the sun is a bright star rather than a blazing presence, and the surface temperatures are low enough that nitrogen, methane, and carbon monoxide can exist as solid ices. But solid doesn't mean rigid the way a rock is rigid, because many ices are viscoelastic under the right conditions, especially nitrogen, and over long time they creep, flow, and reshape terrain. So Pluto's active surfaces are not powered by molten lava, but by soft, volatile ice behaving like an ultra-slow glacier. Nitrogen is the main climate engine because it's volatile enough to sublimate when warmed and condense when cooled. So nitrogen exists as both surface ice and atmospheric gas depending on season, and Pluto's seasons are extreme because its orbit is eccentric and its axis is tilted, and its year is about 248 Earth years, so each seasonal phase can last decades, giving nitrogen enough time to migrate from one hemisphere to another, building thick deposits in cold traps and thinning in warmer regions. This migration is not cosmetic. It can change where Pluto's atmosphere is sourced from and where it collapses onto the ground, meaning Pluto's sky is a seasonal layer that can thicken or partially freeze out, and the surface is the storage reservoir for that sky. Like the planet keeps its atmosphere in a freezer and takes it out when the lighting is right. Methane behaves differently because it's less volatile than nitrogen at Pluto conditions, so methane can remain as persistent frost patches and coatings even when nitrogen is moving more dramatically, and methane is also the key feedstock for haze chemistry. Sunlight and energetic particles break methane molecules apart in the upper atmosphere, and the fragments recombine into more complex hydrocarbons that condense into haze particles, forming layered hazes that can stack like faint horizontal curtains, and those particles slowly settle down to the surface, dusting Pluto with reddish-brown organic material over time. That haze fallout is like chemical snow, and it matters because it changes reflectivity. Dark organic coatings absorb more sunlight, warm local surfaces, and encourage volatiles like nitrogen to migrate away, while bright frost reflects sunlight, stays cold, and becomes a cold trap where volatiles prefer to condense. So Pluto has a built-in feedback loop where color influences temperature, and temperature influences where the ices go, meaning climate is literally painted onto the surface by chemistry and then reinforced by physics. Carbon monoxide also participates as a volatile ice and atmospheric component, tracking equilibrium with nitrogen and methane, and while it's not as dramatic, visually it's part of the same surface-atmosphere exchange story. Gases and ices are constantly trading places depending on sunlight and location. This is why Pluto's surface looks like a mosaic. Some areas are bright because they're volatile-rich and reflect sunlight, maintaining cold conditions that keep the frost stable, and some areas are darker because haze deposition and lack of fresh frost allow them to warm slightly and repel volatiles, making them older-looking and more cratered. Now connect the materials to the shapes. The bright heart-shaped region is not just bright because it's pretty. It's bright because it's dominated by volatile ices, especially nitrogen, stored in a basin-like plain that acts as a climate reservoir and a geological engine. Nitrogen ice can be thick there, and thick nitrogen ice can convect and flow, which is why that plain can look young. Few craters, because convective overturn can continuously renew the surface, erasing, impacts the way a moving glacier erases tracks, and the polygonal cell patterns seen on the plain are consistent with convection cells, a surface texture that is literally the footprint of slow motion underneath. The idea that a volatile ice layer can convect is one of the most alien but simple pieces of Pluto, because it doesn't require high temperatures. It requires only a modest heat flow and a thick layer of material whose viscosity allows motion, and Pluto can supply modest heat through radiogenic heating in its rocky interior, which, over billions of years, can keep certain layers warm enough that volatile ices and possibly subsurface liquids can remain active. The mountains on Pluto complete the material reversal. They're made of water ice, which at Pluto temperatures is strong enough to behave like rock, forming steep, rugged ridges that stand above the volatile plains, and those mountains guide nitrogen glaciers the way rock mountains guide rivers, forcing the moving, volatile ice to flow around obstacles, pool in basins and fill valleys, creating lobate margins and flow patterns that look like glacial landforms but are built from nitrogen rather than water. Methane frost can coat slopes and surfaces, altering reflectivity, while haze deposits can darken other regions. So even within a single landscape, material coatings can change how the ground interacts with sunlight, influencing where volatiles persist. Pluto's tectonic features, fractures, graben-like structures, scarps, suggest that the crust has been stressed and pulled apart, and a major candidate cause is internal expansion from the freezing of a subsurface ocean, because if Pluto had or has a buried liquid layer, freezing would increase volume and push outward, stretching the crust and producing extensional tectonics, leaving long cracks as a preserved record. Even without needing to commit to an ocean as a certainty, the existence of global-scale fractures and young terrains implies that Pluto's interior has not been completely inert, and that the planet's thermal evolution has been dynamic enough to affect the surface. Now bring the binary relationship with Charon into the materials story. Pluto and Charon likely formed from a giant impact, and that impact would have mixed and redistributed material, potentially affecting how volatiles were stored and how the crust formed. And because Pluto and Charon are tidally locked, the system reached a stable rotational state, reducing some forms of tidal heating over time, which means Pluto's present-day activity is more likely dominated by radiogenic heat and volatile-driven surface processes than by ongoing strong tides, unlike moons of giant planets. Charon itself is more of a water-ice bedrock world, lacking Pluto's nitrogen-driven climate, which makes the contrast between them sharper. Pluto is the volatile dancer. Charon is the colder, drier partner. Pluto's smaller moons, tiny, irregular, are likely impact debris remnants, and their odd rotations reinforce the idea that the system's formation was chaotic, but its current motion is calm, again the theme of Pluto. Violence in origin, quiet in present. The Kuiper Belt context then makes the material story feel less weird and more representative, because out there many bodies have surfaces processed by radiation chemistry that creates red organic coatings. Many bodies have mixtures of ices, and the main reason Pluto stands out is size. It's big enough to hold nitrogen and to keep surfaces mobile in localized ways, so Pluto becomes a bridge between tiny Kuiper Belt fragments and larger differentiated dwarf planets, representative of outer materials but complex enough to build landscapes. The calmest way to imagine Pluto's materials at night is to picture a world where the ground is literally capable of becoming sky. Nitrogen ice lying across a plain as a bright frozen sheet, slowly sublimating in sunlight to thicken a thin atmosphere, then condensing back into frost in colder seasons. Methane frost patches sitting like pale dust on slopes, feeding haze chemistry above. Haze layers forming high up, then settling down as reddish-brown organic snow that stains parts of the surface. Water ice mountains standing dark and rigid like rock islands in a sea of volatile ice. And across decades, the planet slowly reorganizing its frosts, brightening some regions, darkening others, while Charon hangs fixed in the same place above it all. Pluto's materials make it feel like the outer solar system's version of a living planet, not because it's warm, but because it's responsive. Responsive to weak sunlight, responsive to small temperature shifts, responsive to long seasons, and capable of moving and renewing itself using the only substances that can move out there, which are the volatiles. And once you let that sink in, you stop expecting drama and start appreciating the quiet power of slow change, the kind of change that doesn't demand attention, but keeps happening anyway until your thoughts finally slow down enough to match it. Pluto is the perfect example of a world that runs on small forces applied for a long time, because nothing about Pluto is loud. No roaring storms, no oceans slamming coastlines, no volcanic fire. But almost everything about it is in motion if you zoom out to the right time scale. And the real trick is understanding that Pluto's main engine isn't heat in the Earth sense, it's phase change. The ability of certain ices to switch between solid and gas with tiny shifts in sunlight and temperature. And once that's in play, Pluto becomes a coupled machine where surface, sky, chemistry, and geology constantly trade roles. Pluto's year is about 248 Earth years, its orbit is tilted and eccentric, and the sunlight it receives is weak but not irrelevant. And because Pluto's surface includes nitrogen, methane, and carbon monoxide, volatiles that can sublimate at Pluto temperatures, small changes in insulation can decide whether those materials stay frozen or join the atmosphere. So Pluto's climate is basically a long seasonal negotiation between frozen reservoirs and a thin, temporary sky. When Pluto warms, nitrogen sublimates and builds a nitrogen-dominated atmosphere, and methane and CO participate, and when Pluto cools, a significant portion of that atmosphere can condense back onto the ground, collapsing pressure, meaning Pluto's atmosphere is not a permanent blanket. It's a seasonal film that can thicken and thin, and the weather is not thunderstorms, it's redistribution. Which hemisphere is donating nitrogen to the air, and which hemisphere is receiving it as frost? Because the atmosphere is thin, you don't get noisy dynamics, but you can still get structure, and the haze layers are the proof. Sunlight and energetic particles break methane apart in the upper atmosphere, and the fragments recombine into heavier hydrocarbons that condense into tiny aerosol particles, forming stacked haze strata like faint curtains, and those particles slowly settle to the surface, dusting Pluto with reddish-brown organic material that darkens terrain, and dark terrain absorbs more sunlight, warming slightly, pushing volatiles away, while bright frosted terrain reflects sunlight, stays cold, and becomes a cold trap that collects more volatiles. So Pluto's chemistry literally paints climate feedback onto the ground. This is how you get a planet that sorts itself into bright, volatile-rich regions and darker, older regions. And once that sorting begins, it reinforces itself, because cold traps keep catching frost and warm regions keep shedding it, turning the surface into a map of stability zones. The heart-shaped region is the most dramatic expression of that sorting, not because it's cute, but because it behaves like a climate reservoir and a geological engine at the same time, a huge basin-like plain, loaded with nitrogen ice that is bright because it's fresh and reflective, and young-looking because the surface is being renewed. Nitrogen ice at Pluto's conditions can behave like a soft solid, creeping like a glacier, and if the deposit is thick enough, and there's even modest heating from below, it can convect, and convection overturns the ice, recycling the surface and erasing impact craters. And that's why a nitrogen plain can look smooth and recently resurfaced, despite being on a world that should have been cratered forever. The polygonal cell textures fit that idea, large-scale convection cells that make the surface look like a giant frozen quilt. So Pluto's young surface doesn't require fire. It requires the right ice behaving like a slow fluid. Water ice, meanwhile, is the opposite. At Pluto temperatures, water ice is rigid and strong, so it behaves like rock, which is why Pluto can have rugged mountains made of water ice rising above volatile plains, and that role reversal is the core of Pluto geology. What you'd call ice on Earth is stone there, and what you'd call air on Earth is ground there, depending on season. Those water ice mountains and ridges then guide the moving volatile ices, forcing nitrogen glaciers to flow around obstacles and into basins, creating lobate margins and valley-filling patterns that look familiar in shape but alien in substance, like a glacier system operating with nitrogen instead of water and with rock made of ice. The cratered darker regions are the other half of Pluto's personality. Ancient terrains preserved because they're not being resurfaced by thick, volatile deposits, coated over time by haze fallout and radiation-processed organics that deepen the reds and browns, and these areas act as memory surfaces, keeping the scars of Kuiper Belt impacts, while the bright plains act as reset surfaces, constantly refreshed. That split, archive versus renewal, makes Pluto feel alive in patches rather than uniformly, and it's exactly what you'd expect on a world where the active material migrates and pools rather than covering the planet evenly. The interior shows up through tectonics, because Pluto has fractures and scarps that look like the crust has been pulled apart in places, and one plausible cause is internal expansion from freezing. If Pluto had a subsurface ocean or warm layer at some point, slow freezing would expand volume and push outward, stretching the shell and cracking it, leaving extensional tectonic features as fossils of interior evolution. Radiogenic heat from the rocky component can supply slow, long-term warmth. Nothing dramatic, just enough to matter over billions of years, especially under thick insulation. And that's why a small world can still have an internal story if you give it time. Add possible cryovolcanic-like emplacement, and you get another pathway for resurfacing. Cold eruptions of slushy water ammonia, mixtures that could flow and freeze, creating smooth deposits or domes, not guaranteed in every detail, but consistent with the broader truth that Pluto has more than one way to rewrite terrain. The big basin that holds the bright plains may itself be an ancient impact scar that became a long-term engine, because a deep basin is a cold trap that collects volatiles, and thick volatile deposits are the ones that can convect and flow, so an ancient violent event can set up conditions for continuous renewal, turning a crater into a climate reservoir and a resurfacing machine. There's even the deeper coupling idea that a massive deposit could influence Pluto's orientation over time through true polar wander, where a body slowly reorients, so a large mass anomaly moves toward an energetically preferred position relative to rotation, meaning surface mass distribution and spin geometry may be linked. Another example of Pluto being a system, not a shell. The atmosphere adds a long-term loss. Story 2. Pluto's gravity is low enough that atmospheric escape matters, and the solar wind interacts with the upper atmosphere, so Pluto is slowly leaking material to space, but the seasonal reservoir keeps the atmosphere going anyway by replenishing it when conditions allow, so Pluto lives in a balance between escape and resupply. And that balance is another reason the atmosphere's existence feels delicate but persistent. The Pluto-Charon pair makes the whole thing feel steadier, because it's not a standard planet-moon setup. Charon is large enough that the barycenter lies outside Pluto, making it a true binary system, and the two are tidally locked, always showing the same face, so from Pluto's surface Charon would hang in nearly the same spot forever, a constant grey disk that never rises or sets, while the sun moves slowly as a small bright lamp, and that sky geometry creates a weird calm anchor through century-long seasonal changes, like no matter how the frosts migrate and the atmosphere thickens or thins, the companion stays fixed, watching. Charon itself is more of a water-ice bedrock world without Pluto's nitrogen-driven breathing, yet it shows its own tectonic history, reinforcing the theme that even outer icy bodies can evolve internally. The smaller moons are like leftover fragments, likely impact debris, adding texture to the system's origin story, early chaos that settled into quiet orbits. Pluto's orbital behavior also slots neatly into outer solar system structure rather than randomness, because Pluto is stabilized by resonance with Neptune. Its orbit is eccentric and tilted, but protected by repeating gravitational timing that prevents close encounters. So Pluto's path is a disciplined choreography that can persist for billions of years, and that same resonance pattern is shared by other Kuiper Belt objects, showing Pluto is one of a family shaped by Neptune's migration and resonance capture. This family context is the real antidote to the whole demotion obsession, because Pluto's importance isn't a label, it's that it became the first Kuiper Belt world we saw as a landscape, proving the outer solar system is not a graveyard. It's a slow laboratory where volatile cycles, radiation chemistry, and cold geology can produce real complexity. The emotional correction New Horizons forced is still worth holding, because it changes how you imagine Pluto. The sun is distant but sharp, shadows are hard, the sky is thin but layered when hazes are present. The horizon can glow faintly blue from scattering in haze particles. The bright plains can look like frozen light, the mountains like black stone, the dark regions like rusted dust, and overhead Charon hangs steady like a ceiling fixture. And if you want to turn all of that into something your brain can follow at night, the simplest pattern is the cycle itself. Nitrogen ice on the ground becomes nitrogen gas in the air. Gas becomes haze chemistry. Haze becomes surface coating. Coating changes reflectivity. Reflectivity changes temperature. Temperature moves the frost. Frost thickens in basins. Thick frost convects and flows. Flow erases craters. Tectonics cracks the crust as interiors evolve. And through it all, the binary pair rotates in silence through the Kuiper Belt on a 248-year loop. Pluto is not a world of events, it's a world of processes, and processes don't need volume, they need persistence, which is why Pluto works so well for sleep. Everything is happening, but nothing is urgent, and the more you let Pluto time take over, decades for a season, centuries for an orbit, millennia for resurfacing, the more ridiculous your fast, anxious thoughts start to feel, because Pluto doesn't reward speed, it rewards repetition. And if you match that, your mind naturally does what Pluto does out there. Slows down, cycles quietly, and fades. Pluto's surface can be read like two competing stories written on the same globe. One story is ancient and impact-scarred, a record of Kuiper Belt collisions preserved because nothing has bothered to erase it, and the other story is young-looking and actively refreshed, a record of volatile ice motion and seasonal cycling that keeps rewriting certain regions. And the reason both stories exist at once is that Pluto's activity is not uniform. It's localized where the right materials collect, where basins concentrate volatiles, and where slow internal warmth and surface feedback loops can keep things moving. The ancient story lives in the darker, heavily cratered terrains, places where impacts accumulated over billions of years, where haze, fallout, and radiation chemistry have gradually built reddish-brown coatings, and where volatile ices do not sit thick enough to convect or flow away the scars. So these regions behave like an archive, a cold museum of time, where each crater is a timestamp. The young story lives in volatile-dominated basins and plains, especially the bright nitrogen-rich deposits that can flow, overturn, and erase craters. And the cleanest example is the bright plain within Pluto's heart region, where the surface is smooth and patterned with large polygons, consistent with convection cells in a thick layer of nitrogen ice, which is not a poetic interpretation but a mechanical one. Warm nitrogen ice rises, cool nitrogen ice sinks, the surface cycles, and craters get swallowed by the slow churn. The key to understanding why nitrogen can do this is the role reversal of materials. At Pluto's temperatures, water ice becomes rigid and acts like rock, while nitrogen and methane ices can be soft enough to deform over time. So in Pluto geology, the hard framework is water ice bedrock, and the mobile agent is volatile ice, which behaves like an ultra-slow glacier, creeping around obstacles, pooling in depressions, and flowing along gradients. This is why Pluto can have mountains, rugged ranges made of water ice, that can support steep slopes, and those mountains act like the walls of basins and the dividers of flow, shaping where volatile deposits can sit and how they migrate. These mountains also prove that Pluto's crust has strength, and that geological processes have either uplifted or exposed water ice material, because you don't get tall, rugged relief without a stiff structural layer. Once you accept water ice as bedrock, the rest becomes easier. Basins become cold traps where nitrogen collects. Cold traps become climate reservoirs because nitrogen can become atmosphere and return as frost, and thick nitrogen deposits become geological engines because they can convect and flow, meaning climate storage and geological resurfacing become the same thing in the same location. Pluto's climate is built around this storage because Pluto's year is about 248 Earth years, its orbit is eccentric and tilted, and sunlight shifts across hemispheres over decades, so nitrogen sublimation and condensation migrate from one region to another on timescales long enough to build thick deposits in cold traps, and because Pluto's atmosphere is thin, it doesn't buffer the surface the way Earth's does. The surface responds more directly to sunlight. So reflectivity, albedo, becomes a major controller. Bright frost reflects sunlight and stays cold, helping it persist, while dark, haze-coated ground absorbs sunlight and warms slightly, pushing volatiles away, and that albedo feedback helps Pluto segregate into bright, volatile-rich zones and dark, volatile-poor zones, reinforcing the patchwork. The haze itself is part of the loop. Methane in the atmosphere is broken down by sunlight and energetic particles, creating complex hydrocarbons that condense into haze particles, forming layered hazes high above the surface, and those particles settle out like chemical snow, coating the ground with reddish-brown organics that darken it, and that darkening can warm the surface enough to discourage nitrogen frost, shifting where nitrogen wants to reside, which then shifts where the atmosphere is sourced and where it collapses, so the sky feeds the ground and the ground feeds the sky. This is Pluto's signature, an atmosphere that is literally surface material in gas form, a sky that is temporary and seasonal, and a surface that stores and releases the sky. The tectonic features provide the interior thread that ties into this surface system, because Pluto shows fractures and scarps suggesting extensional stress, and one plausible driver is internal expansion from freezing. If Pluto once had a subsurface ocean or warm layer beneath its ice shell, gradual freezing would expand volume and push outward, stretching and cracking the crust, and those cracks can remain as fossils even if the ocean is now mostly frozen, meaning Pluto's present landscape includes evidence of past internal warmth. Radiogenic heating from Pluto's rocky component can supply slow, long-term heat, not enough for silicate volcanism, but enough to matter for maintaining a subsurface liquid layer for long periods or for softening certain ices, especially under thick insulation. So Pluto's interior doesn't need to be dramatic, it only needs to be persistent. Possible cryovolcanic-like features, cold eruptions of slushy water-ammonia mixtures, would fit that persistence model too, offering another mechanism to emplace smooth terrain without requiring high temperatures. And even if the exact interpretation of specific features is debated, the broader point is solid. Pluto has more than one potential resurfacing pathway, and that's why it has both young-looking and old-looking terrain. The binary relationship with Charon adds a constant sky geometry that makes Pluto feel steady even as everything else cycles, because Pluto and Charon are tidally locked and orbit a barycenter outside Pluto, making them a true binary pair. So from Pluto's surface, Charon would hang in nearly the same spot forever, never rising or setting, a constant companion through century-long seasons, while the Sun is a small, sharp disk that moves slowly, and that constant presence is psychologically important for sleep narration because it gives you a fixed reference point in a world defined by slow change. Charon's own geology, more dominated by water ice and lacking Pluto's volatile breathing, provides contrast that makes Pluto's volatility stand out even more, like one partner is stable and dry while the other is seasonally alive. Pluto's orbit itself also carries the theme of order inside weirdness. It is eccentric and tilted, but stabilized by resonance with Neptune that prevents close approaches, meaning Pluto's path is a disciplined choreography, a repeating timing relationship that can last for billions of years, and that resonance is not unique to Pluto but shared by other Kuiper Belt objects, showing Pluto is part of a structured family shaped by Neptune's migration and resonance capture. All of these threads, volatile mobility, albedo feedback, haze chemistry, patchwork resurfacing, tectonic cracking, binary locking, resonant orbit, combine into one calm truth. Pluto is a world where nothing needs to happen quickly for everything to be happening, because the dominant processes are slow by nature and powerful by persistence. The best way to picture it at night is to stand on the edge of a bright nitrogen plain, where the surface is patterned with huge polygons like a frozen quilt, to feel the idea that the plain is slowly overturning under your feet even if you can't see it, to look toward dark, cratered hills coated with reddish haze, fallout that preserve ancient impacts, to see water ice mountains rising like black stone islands between the terrains, to look up and find Charon fixed in the same spot like a silent companion, and to remember that the atmosphere you might be breathing there is borrowed from the ground and will return to the ground when the season shifts, because on Pluto the sky is a phase of ice. Once you hold that scene long enough, your mind stops demanding a climax, because Pluto's whole identity is continuous cycling, frost to air, air to haze, haze to surface, surface to frost, repeating in decades, centuries, and millennia until your own thoughts finally decide to follow the only reasonable thing a Pluto story asks of you. Slow down and drift. Pluto's orbit is one of the most misunderstood parts of its story because people see eccentric, tilted, crosses Neptune's distance and assume instability, danger, randomness, like Pluto is some chaotic rebel. But Pluto is actually a disciplined object in a locked rhythm, and the fact that it stays safe for billions of years is proof that weird-looking motion can still be stable when resonance timing is doing the guarding. Pluto's orbit is eccentric, meaning its distance from the Sun varies a lot over its long year of about 248 Earth years, and it's inclined, meaning it's tilted relative to the plane most planets orbit in, so yes, it looks different, but difference doesn't automatically mean unstable, especially in the outer solar system, where resonances are common and where Neptune's migration early on captured objects into repeating timing relationships. Pluto is in a 3.2 resonance with Neptune, which means for every 3 orbits Neptune makes, Pluto makes 2, and the important part isn't the ratio itself, it's the repetition. The same orbital geometry repeats in a way that prevents Pluto from being in the same place as Neptune at the same time, in a way that would lead to a close approach, like 2 runners on a track who lap at a consistent pattern that keeps them from colliding. This resonance creates a kind of protective choreography. Pluto can be closer to the Sun than Neptune at perihelion, and still never come close to Neptune because the timing ensures Neptune is elsewhere when Pluto is in the crossing region. So crossing orbits on paper does not mean crossing bodies in real space at the same time. This is the first calm truth. Pluto's orbit looks messy in a flat diagram, but in actual 3-dimensional space and time, it is regulated. Pluto is also part of a broader resonant population called Plutinos, other Kuiper Belt objects in the same 3-2 resonance, meaning Pluto's orbit is not a lonely anomaly. It's a signature of Neptune's gravitational influence shaping a whole family, and that family exists because Neptune likely migrated outward early in solar system history, sweeping resonances through the outer disk and capturing objects into stable patterns, which reorganized the Kuiper Belt into dynamical classes. Resonant objects, classical objects on more circular orbits, scattered disk objects on more extreme paths, and so on. Pluto's resonance tells you it was likely caught in this migration process, and that makes Pluto's orbit a fossil of early solar system evolution, a preserved trace of how giant planets moved and rearranged debris. Pluto's eccentricity and inclination also matter physically because they control sunlight distribution and seasons, not just climate, but volatile stability. When Pluto is farther from the Sun, it's colder and more of its nitrogen atmosphere can freeze onto the ground, while when it's closer, more nitrogen can sublimate and build a thicker atmosphere, and because the year is so long, these changes unfold over decades, meaning the orbit is directly connected to Pluto's breathing, the atmosphere thickening and thinning with seasonal and orbital phase. The tilt adds another layer because it changes how sunlight hits different latitudes over time, causing long-lasting polar and hemispheric seasons that can drive volatile migration across the surface. So Pluto's orbit is not just a path, it's a climate program that runs for centuries per cycle. The orbit also gives Pluto time for slow feedback loops. Hazes form, settle, darken regions, shift albedo, move frosts, and because the seasons are long, those albedo-driven migrations can accumulate thick deposits in cold traps and thin deposits elsewhere, reinforcing the patchwork nature of Pluto's surface. Pluto's orbital stability also makes the Pluto-Charon system feel even more like a paired traveler. While Pluto and Charon orbit each other every few days in a tidally locked dance, the whole pair moves around the Sun in the long, resonant loop, maintaining a stable relationship with Neptune's orbit over billions of years. So the binary system is nested inside a resonant system, a rhythm inside a rhythm. The calmest mental picture for Pluto's orbit is to imagine the solar system not as a flat disk, but as layered lanes in 3 dimensions. Neptune moving in a relatively circular path, Pluto moving in a tilted eccentric path that sometimes takes it closer to the Sun than Neptune, sometimes far beyond, but always with timing that keeps the two from meeting, like a long, slow waltz where partners pass near the same floorboards but never step on each other's feet. Then imagine that this waltz isn't unique. Other Plutinos follow similar rhythms, locked into the same resonance, and beyond them are other populations on different resonances or more circular paths, all shaped by Neptune's ancient migration. So the Kuiper Belt becomes not a random scatter, but a structured field of orbits, like a swarm with invisible rules. Pluto's orbital speed also changes, faster near perihelion, slower near aphelion, which is normal orbital mechanics, and that changing speed contributes to how long Pluto spends at different distances, which matters for climate and volatile stability, because a long time spent far away means a long time spent cold, allowing frost deposition and atmosphere collapse phases to persist, while the faster pass closer in produces a shorter period of relatively stronger heating, and this uneven time distribution influences how much atmosphere can build and how volatiles redistribute in each cycle. The orbit also affects interaction with the solar wind and radiation environment. Farther out, solar wind density is lower, sunlight is weaker, but high-energy particles still exist, and the thin atmosphere and surface ices are processed by radiation chemistry over long time, producing organic residues and changing surface colors. And because orbital cycles repeat, the surface is continually reprocessed. Fresh frost can cover older, dark material, then haze fallout can darken again, then frost migrates again, meaning Pluto's orbit creates repeated phases of exposure and covering. The famous classification drama around Pluto distracts from this more meaningful truth. Pluto's orbit and resonance make it a key piece of evidence about solar system architecture, because you don't get stable resonant populations without a history of migration and capture, and Pluto's current path is one of the easiest ways to see the imprint of Neptune's long-term gravitational shaping. In other words, Pluto is not a misfit, it's a textbook example of how the outer solar system organizes itself through resonance. For sleep narration, the orbit story is soothing because it's order disguised as weirdness, a tilted path that looks chaotic until you include timing, a crossing that isn't a collision because resonance keeps the schedule, a long year that stretches seasons into decades, and a rhythm that repeats across billions of years, which is a perfect mental pattern to sink into. Pluto circling the Sun slowly, Charon circling Pluto in a locked stare, Neptune pacing its own lane, and resonance acting like an invisible metronome, ensuring everything keeps its distance, stable, predictable, and quietly repeating until your own thoughts finally accept that repetition is enough and stop trying to force an ending. Pluto's night sky is the fastest way to make the planet feel real because it forces you to internalize the distance in a sensory way. The Sun becomes a bright star rather than a blazing disk. The light is sharp and cold. Shadows are hard because the atmosphere is thin, and the most dominant object in the sky isn't the Sun at all. It's Charon. Huge, close, and fixed in nearly the same position because Pluto and Charon are tidally locked, which turns the sky into something steady and minimal, almost like a room with one permanent lamp that never moves. On Pluto, the day is about 6.4 Earth days long, because that's the orbital period of the Pluto-Charon binary rotation, and because they are locked, Pluto always shows the same face to Charon, and Charon always shows the same face to Pluto. So if you stand on the hemisphere that faces Charon, you don't get a normal moon cycle. You get a constant companion hanging overhead, slowly wobbling a little due to libration but never truly rising or setting, and if you stand on the opposite hemisphere, you never see Charon at all, which is an extreme sky division that feels almost unfairly alien. Half the planet gets a huge permanent moon, the other half gets none. The idea that a moon can be permanent is already calming, because it means the sky doesn't feel busy, it feels anchored, and on Pluto that anchor is massive. Charon would appear far larger than Earth's moon does from Earth, dominating the sky like a grey world hanging close, with subtle surface contrast and a cold, matte look. And because the sun is distant, Charon's illumination and Pluto's own twilight gradients become more noticeable, giving the horizon a clean, crisp feel. The sun itself would be small but intense, more like a brilliant star that still casts defined shadows, because even a small apparent disk can be bright enough to illuminate sharply when there's minimal atmospheric scattering. And depending on whether Pluto's atmosphere is more present or more collapsed in a given season, the sky could range from nearly black to faintly tinted by haze. When the atmosphere is present, layered hazes can scatter sunlight and create a faint blue limb near the horizon, a soft gradient that looks almost gentle. And that's one of the weirdest emotional contrasts on Pluto. A world that should feel dead and harsh can still produce a soft sky glow because chemistry creates aerosols that scatter light. Those hazes are created by methane photochemistry, sunlight and energetic particles breaking methane apart, building more complex hydrocarbons that condense into tiny particles, so the sky's softness is literally a chemical product, and those particles settle down and coat the ground as reddish organic material, meaning Pluto's sky is not only scenery, it's a slow depositional process that changes the surface. At night, with the sun gone below the horizon, the sky would be brutally dark because there's no nearby bright source, and stars would be intense and sharp, not necessarily brighter in any mystical way, but less washed out by atmospheric scattering, and the Milky Way would cut across the sky with high contrast, and because Pluto is far out, planets that dominate our night sky would be reduced to small points. Jupiter would be a bright star-like object rather than a large disk to the naked eye. Saturn even fainter, and Earth would be an extremely bright but tiny point that you wouldn't immediately recognize unless you knew where to look, because Pluto doesn't give you familiar planetary landmarks. It gives you a field of stars and one huge nearby companion if you're on the right hemisphere. The sense of isolation comes from the lack of motion. On Earth, the sky changes constantly because of fast rotation and atmospheric effects. But on Pluto, the rotation period is days, so the sky wheel turns slowly. And because Charon doesn't rise or set, you don't get that moving anchor point either, so the sky's changes are mostly subtle, slow star drift, slow sunlight angle changes, and over much longer time, the seasonal shift in haze and atmosphere thickness. Even the seasons are sky events. Over decades, Pluto's atmosphere can thicken when nitrogen sublimates and collapse when nitrogen freezes out, meaning the sky can become more hazy and layered during warmer phases and clearer and more black during colder phases. So Pluto has sky seasons where the presence of a faint horizon glow can come and go. The ground beneath that sky is equally quiet but not inert. Nitrogen ice plains can convect slowly, erasing craters over time. Glaciers of nitrogen can creep around water ice mountains. Methane frost can dust slopes, and haze particles can fall like fine organic snow, darkening regions and shifting albedo, which in turn shifts where volatiles settle, so even under a still sky, the surface is participating in long cycles. From a practical sensory standpoint, the cold would be extreme. But for narration, you don't need to lean on discomfort. You lean on precision. The sharp shadows, the matte ice, the silent plains patterned with polygons, the rugged black water ice mountains, the thin air sometimes present like a whisper, and above it, Charon hanging steady like an overhead world. Imagine standing on the edge of a bright nitrogen plain at dusk. The sun is low, small and brilliant, casting long shadows from water ice ridges. The haze, if present, turns the horizon into a faint gradient, layered bands barely visible. The ground is pale and smooth, textured with giant convection polygons like a frozen quilt. Nearby, darker terrain rises, cratered and coated with reddish-brown organics. And in the sky, Charon sits massive and unmoving, a grey disk that makes the whole scene feel like you're standing inside a binary system rather than on a solitary planet. Then the sun slips away, and because there's so little atmosphere to keep the light lingering, twilight fades quickly into darkness, and the stars appear hard and dense, the Milky Way bright and textured, and Charon remains, now a dark silhouette or a faintly lit disk depending on angles, still fixed, still steady. The deep calm of Pluto's sky is that it offers almost no distractions, no clouds racing, no moonrise, no weather fronts, only slow rotation, long seasons, and a permanent companion. So your mind has nothing to chase, and if you let that stillness settle, your thoughts naturally stop trying to move fast, because the sky above Pluto doesn't reward speed, it rewards patience, and patience is exactly what you need to fall asleep.